Hello everybody, and welcome to the supplementary handout for section 5.3. We're going to be looking at exercise 1 on this handout. Let's start by reading the instructions that they're giving us here. So for these problems, they'd like us to use the indicated value of u to rewrite the given integral in terms of the variable u. Okay, and just a reminder, we're not being asked to actually evaluate this integral. We're really just being asked to do a u substitution, to take this integral and to rewrite it in terms of the new variable. Okay, so they're giving us a value of u equals e to the x. So we're going to go through the usual steps that we would for a u substitution. So if u is e to the x, then the derivative is going to be e to the x, and we'll stick a dx on the end. And then we'd like to get the dx by itself, so we'll do that by dividing both sides by e to the x. Okay, again, just the usual steps that you go through when you do a u substitution. Okay, so the integral that we're starting with looks like the square root of 1 minus e to the 3x. And the goal, again, is to do this substitution to rewrite our integral in terms of u. Okay, well, how do we do that? Okay, it's not so obvious how we actually do the substitution in this case. We need to make an algebraic observation here. And I'm going to just go ahead and show you what this is. Okay, and this will remind you a little bit about rules of exponents. So the e to the 3x that you see, we can actually rewrite that as e to the x cubed. Okay, do you see why we can get away with that? You might remember a rule of exponents that says that when you take a power to a power, you multiply the exponent. So this e to the x raised to the third power, if you multiply the x and the 3 together, you get the 3x that's over here. Okay, so those are equivalent, even though they look a little bit different. Okay, by making that observation, we can kind of see what we need to do to substitute into our integral here. So the e to the x that you see here, that's equal to the u that they gave us, so we can make that substitution. We're going to get 1 minus u cubed in the integral, and then dx, we can see from our work over here to the right, is equal to du over e to the x. We'll make that substitution as well. Okay, and the question is, are we done with this substitution? Not quite, because we've got a leftover e to the x that didn't cancel for us. Okay, so we need to replace that with something. So here's that process of going fishing again. We need to go fishing for an e to the x. Luckily, in this case, we don't have to go fishing very far, because we can see right here that e to the x is equal to u. Okay, which means that we're free to substitute u for that e to the x that we see. Okay, so our integral is going to become square root of 1 minus u cubed times du over u. Okay, and I'm going to remind you of why that's true. We're just making the observation that u is equal to e to the x, and so we did one more substitution. Okay, and at this point, we're essentially done with the problem. We've taken our integral and transformed it into an integral that has u's in it. If we wanted to, we could do a little simplification here. Okay, and rewrite our answer by putting the u together with the function and writing the du at the end. Okay, I'm going to take that as my final answer, but you could have also taken the previous step up here and called that your final answer. Either way would be okay.